A penguin stands completely still on a sheet of Antarctic ice. The wind screams across the frozen landscape at nearly 100 kilometers per hour. Snow blasts through the air like tiny shards of glass. The temperature drops below -40 degrees Celsius, cold enough to freeze exposed human skin in minutes. And yet this penguin stands there barefoot. No boots. No thick fur socks. No heated shelter. Just two skinny feet pressed directly against solid ice. Which raises an impossible question. Why don't penguins' feet freeze off? At first glance, penguins seem badly designed for Antarctica. Their bodies look warm and insulated, covered in dense waterproof feathers and thick layers of fat. But their feet? Their feet look fragile, thin, exposed, almost defenseless. If a human tries standing barefoot on ice that cold, pain would arrive instantly. Blood vessels would constrict. Tissues would begin freezing. Cells would start dying. So how does a penguin survive doing this every single day of its life? The answer begins deep inside its legs. Most animals lose heat because warm blood from the body travels into colder limbs and releases warmth into the environment. The farther blood moves from the warm core, the more heat escapes. Penguins solve this problem with one of nature's smartest engineering tricks, a biological heat exchange system called countercurrent circulation. Inside a penguin's legs, arteries carrying warm blood from the heart are packed tightly against veins carrying cold blood, back from the feet. The two blood streams move past each other in opposite directions. As warm blood travels downward, it transfers most of its heat into the colder blood returning upward. By the time blood finally reaches the feet, it has already cooled dramatically. And by the time cold blood leaves the feet, it has been reheated before returning to the body. This creates a remarkable balance. The feet remain only slightly above freezing, just warm enough to avoid tissue damage, but cold enough that very little heat escapes into the ice. In other words, penguin feet are supposed to be cold. Nature didn't design them to stay warm. Nature designed them not to waste energy. And in Antarctica, wasting heat can mean death. But that's only part of the story. Penguin feet are also built from tissues that require surprisingly little oxygen and warmth to function. Penguins solved this problem with one of nature's smartest engineering tricks, a biological heat exchange system called countercurrent circulation. Inside a penguin's legs, arteries carrying warm blood from the heart are packed tightly against veins carrying cold blood, back from the feet. The two blood streams move past each other in opposite directions. As warm blood travels downward, it transfers most of its heat into the colder blood returning upward. By the time blood finally reaches the feet, it has already cooled dramatically. And by the time cold blood leaves the feet, it has been reheated before returning to the body. This creates a remarkable balance. The feet remain only slightly above freezing, just warm enough to avoid tissue damage, but cold enough that very little heat escapes into the ice. In other words, penguin feet are supposed to be cold. Nature didn't design them to stay warm. Nature designed them not to waste energy. And in Antarctica, wasting heat can mean death. Unlike mussels, which constantly burn energy and produce heat, penguin feet contain large amounts of tendon and bone. That means the feet can safely operate at temperatures that would seriously damage other animals. Scientists studying emperor penguins discovered something shocking. Sometimes their foot temperatures hover barely above 0 degrees Celsius while the rest of the body remains warm and stable. Humans could never tolerate that. Yet penguins walk, balance, slide, and survive perfectly well. Still, even with these adaptations, standing directly on ice all day sounds dangerous. So penguins developed behavioral tricks too. Watch penguin closely, and you'll notice it rarely places its entire foot flat against the ground. Instead, it often rocks backward onto its heels and tail, minimizing contact with the ice. Some species even tuck one foot up into their feathers while balancing on the other, switching periodically to conserve warmth. And when conditions become truly brutal, penguins turn to one of their greatest survival strategies: each other. Thousands of emperor penguins gather into tightly packed huddles during Antarctic winters. From above, they look like a living black and white storm cloud shifting slowly across the ice. But inside the huddle, something incredible happens. Penguins constantly rotate positions. Those on the freezing outer edge slowly move inward while warmer penguins drift outward. No single penguin remains exposed for too long. Temperatures at the center of these groups can rise dramatically compared to the deadly cold outside. It's survival through cooperation. And emperor penguins need every advantage they can get because Antarctica is one of the harshest places on Earth. During winter darkness, male emperor penguins fast for months while protecting eggs balanced carefully on top of their feet beneath warm skin, folds called brood pouches. The eggs never touch the ice directly. If they did, the developing chick inside could freeze within minutes. So the fathers stand there for weeks without eating, barely moving, enduring blizzards powerful enough to knock humans flat, all while balancing precious eggs above frozen ground using the same feet that somehow refuse to freeze. But feet aren't the only problem Antarctica creates. Penguins also face another dangerous challenge: water. Ironically, even surrounded by ice and snow, Antarctica is technically a desert. Fresh liquid water is rare, and saltwater oceans create their own problems. Drinking seawater would poison most animals over time because of the salt. Penguins solve that too. Special glands near their eyes filter excess salt from their bloodstream. The concentrated salt solution then drips from their beaks or sneezes out. So if you ever see a penguin shaking its head and spraying tiny droplets, it may actually be blasting salt from its body. Nature engineered these birds for a world that should be almost impossible to survive in. And yet penguins don't merely survive there. They thrive. Some species dive hundreds of meters beneath freezing water chasing fish and squid. Others travel enormous distances across sea ice. Emperor penguins can hold their breath for over 20 minutes during deep hunts beneath the Antarctic surface. That icy water creates another puzzle. Water steals body heat far faster than air. So how do penguins avoid freezing while swimming? Again, feathers become the secret weapon. Penguin feathers are unlike the feathers of most birds. They are densely packed, overlapping tightly to trap insulating layers of air close to the skin. A waterproof outer coating prevents icy seawater from penetrating deeply. Beneath that lies thick insulating down and fat reserves. The trapped air even makes penguins slightly buoyant. Sometimes they release streams of bubbles while swimming at high speed, reducing drag and helping them rocket through the water like living torpedoes. And despite their awkward waddling on land, penguins are astonishingly graceful underwater. Their wings evolved into rigid flippers capable of flying through the ocean. Some species reach speeds over 30 kilometers per hour while hunting. To predators below, they don't look clumsy at all. They look built for perfection. Still, Antarctica remains unforgiving. Leopard seals patrol beneath cracks in the ice waiting for penguins to jump into the water. Giant petrels circle overhead hunting weak chicks. Blizzards can separate parents from offspring in endless white storms. And climate change now threatens the sea. Ice many penguin species depend on for breeding and feeding. Entire colonies are struggling, as warming temperatures disrupt fish populations and melt critical habitats, which makes penguins even more extraordinary. Because every surviving penguin represents millions of years of evolution solving impossible problems. How to walk on ice without freezing, how to swim in deadly water without losing heat, how to raise chicks in darkness colder than most freezers on Earth. And perhaps the strangest part is this. The very thing that seems like a weakness, their cold feet, is actually one of their greatest strengths. Because in Antarctica, survival doesn't belong to the warmest creature. It belongs to the one that wastes the least heat.